Hello everyone, welcome to this video on learning mathematics through concepts and examples. Today we are going to look at a couple of examples problem on implicit differentiation and finding the equation of tangent line. Okay, here is our first example. We are asked to find the equation of a tangent line to this function y equal to e raised to 2x at x equal to natural log of 3 divided by 2. Okay, so let's begin with the given function. So here we have y equal to e raised to 2x, e raised to 2x. And we are asked to find the equation of tangent line. So in order to find the equation of a straight line, like tangent, we need the point and the slope. Point means x comma y, but they have given only x. So what we need to do is we need to find the value of y. So if I want to find the value of y, all I need to do is plug in the value of x from here. So that will be y equal to e raised to 2 times x. X is natural log of 3 divided by 2, which is same as like this, natural log of 3 divided by 2. Okay, then you can see that 2 and 2 get cancelled. We get y equal to e raised to natural log 3. And you can see that the exponential function and logarithmic function, e and natural log, these are inverse, so they undo each other. So the result will be 3. Or we get y equal to 3. So meaning of that is the point, okay, the point which is x1 comma y1 at which we want to find the tangent line is, your x value is natural log 3 divided by 2 and the y value is 1. Okay, that is the point. Once we get the point, next thing we want to do is we want to find the slope. Slope of the tangent line. So slope is the derivative. So what we do now is we find the derivative at x equal to natural log 3 divided by 2. So let's first find derivative. So y prime, the derivative is equal to, this is our function. So the derivative would be e to the 2x. The derivative of e to the 2x is 2 e to the 2x. So this implies slope will be equal to 2 times e raised to 2 times. So we plug in the value of x, natural log 3 divided by 2, natural log 3 divided by 2, or we get m equal to, okay, let's simplify. 2 and 2 cancel. E raised to natural log 3 is 3. We have seen in the previous step there. And 3 times 2 is 6. So the slope is 6. So we have the point. Okay, we have the point. We have the slope. Once we have the point and slope, we can easily find the equation of tangent line. So equation of tangent line is y equal to m times x minus x1 plus y1. So that is the equation. We plug in the values there. Y equal to, slope is 6, then x minus x1, the value of x1 is here, which is natural log 3 divided by 2, natural log 3 divided by 2 plus y1, the value of y1 is 1. So we can distribute and simplify that. So y equal to 6 times x, that is a 6x minus, when you multiply here, it will be 6 log 3 divided by 2, that is 3 log 3, 3 natural log 3, and at the end we have plus 1. So that is the equation of the line tangent to this given function at x equal to natural log 3 divided by 2. Okay, that is the first example for this video. Let's move on to second example. Okay, here we have the implicit function. Consider the function. You can just say function, right? We have a function here. We are asked to use the implicit differentiation to find the derivative. So let's first find the derivative. So we have, let me write it down. We have 2x cubed plus y cubed equal to 3. So we can keep y on the left-hand side and move everything on the right, like that. Then we can find the derivative with respect to x. So let's do that. Differentiating with respect to x, we get, okay, derivative of y cubed is 3y squared dy over dx equal to derivative of 3 is 0 and derivative of negative 2x cubed is using the power rule, that is negative 6x squared. Negative 6x squared. Now if you divide on both sides by 3y squared, the derivative would be equal to negative 6x squared over 3y squared, or the derivative is equal to negative, and then 6 divided by 3 is 2, and both x and y are squared, so I can write x over y squared. So that is the answer to the first part. We are asked to find the derivative, and we got that derivative. Okay, that is first part. Now let's look at the second part. In the second part, we are asked to find the equation of the tangent line at 1, 1. So how do we find the equation of tangent line? We need the point and the slope. Point is already given here. So this is our x1, y1. Okay, x1 is 1, y1 is also 1. And the other thing we need is the slope. So slope m is the value of this derivative at 1, 1. So if we plug in 1, 1, that will be negative 2 times 1 over 1 squared, which is equal to negative 2. So the slope is negative 2. You have the slope, you have the point. So we can find the equation easily. So let's write it down. Now equation of tangent line. Equation of tangent line is y equal to m times x minus x1 plus y1. So we'll plug in the values. So we can write y is equal to, slope is negative 2, x minus x1 is 1, and y1 is also 1. So we get y equal to, if you distribute that negative 2, negative 2x, negative and negative multiplied to get positive. So negative 2 times negative 1 is a positive 2. Then we have plus 1. So finally, we get the equation y equal to negative 2x plus 3. So that is the equation of the tangent line. Okay, that is the equation of the tangent line to this curve at 1, 1. Okay, that is the second example. Let's do one more example in this video. Here comes the next one. We are asked to use the implicit differentiation to find the derivative of this function. So let's begin with the given function. So what we have is sine xy equal to x squared plus y. So we'll bring that the y on the left-hand side because we want to keep all y on the left. So sine xy minus y equal to x squared. So x squared is on the right, everything with y on the left-hand side. Now we can do the differentiation. So differentiating both sides with respect to x. So if we differentiate with respect to x, let's see what we get. This function on the left, sine xy, is a composite function. Your outside function is sine function, inside function is the product of x and y. So because it is the composite function, we use the chain rule. So first we find the derivative of outside function, keeping the inside same. So derivative of sine is cosine. Keep the inside same, so cosine xy. Then multiply by the derivative of inside function. The derivative of this product, so we have to use the product rule. Product rule says first function, which is x, times the derivative of second, dy over dx, plus second function, which is y, multiplied with the derivative of first. Derivative of x with respect to x is 1. Then minus, we have y here, derivative of that y with respect to x is dy over dx, and then equal to, On the right hand side, we have x squared. Derivative of x squared is 2x. Okay, now after that, you can see that outside this bracket, we have this cosine xy attached. So we distribute. So let's distribute and see what we get. So if I multiply here, okay, cosine xy multiplied to x times dy over dx, that is x times cosine xy times dy over dx. Then we have a plus. And when we distribute there, that is y times 1, y multiplied with that. So it is y times cosine xy. Then we have minus dy over dx equal to, on the right hand side, we have a 2x. Now from this first term and the third term, I can factor this dy over dx out. So dy over dx is factored out. So from here, we are left with x cosine xy, x cosine xy. And from the third one, if we factor this dy over dx out, it will be -1, like that. Then equal to, on the right hand side, we already have 2x. Okay, we already have 2x. We'll move this quantity on the other side because this one does not have dy over dx, so we can move it to the right. It's positive. If you subtract and move it to the right hand side, it'll be minus. So minus y times cosine xy, like that. So dy is multiplied with that. So dy over dx is multiplied with that quantity inside the bracket. So if I want to find dy over dx by itself, I have to divide by that quantity on both sides, and we get our final answer. Let me write here. Dy over dx is equal to 2x minus y cosine xy, which is already on the right hand side. We divide that by the quantity inside the bracket, that is x times cosine xy minus 1. So that is the derivative of that implicit function which is given here. So we use the implicit differentiation to find the derivative of that function. It has, few steps that we need to, solve carefully, because it also involves things like distribution and factoring, and then, solving for dy over dx by itself. Okay, that's all in this video. I hope you find this video helpful. Thank you so much for watching.